We should all be on page 42. As a reminder, guys, listen. As a reminder, the quiz closes at 11:45 tomorrow night. I've given you a day in class. There's been time, like yesterday, you had half a class period to work on it. You know, guys, when I'm talking to you, please not talk. If I need to make some seat changes, I will. This class is getting a little chatty at the wrong times, right? What was I saying? So you know absences happen, especially on Fridays, and so you won't get that last reminder from me about the quiz. So whatever you need to do to remind yourself to get that quiz done, make sure you do, okay? So we're going to get started. Notes are not very long or difficult. I don't think you will be using your calculators quite a bit, so make sure you have those ready to go. And laptops closed. You shouldn't be listening to music at the same time, all that stuff, okay? Staying focused, awake, not talking. Interrupting me and asking for help. I don't mean to use the word interrupting. Asking me for help, of course, at any point if I'm not explaining it well. Okay, continuing on with exponential functions, we're going to do some of the same stuff we've been doing and some new word problems that are not difficult at all. All right, lots of good review of things we've done that are huge concepts on the AP exam, and I'll keep pointing those out. Okay, so there are many scenarios in the world that can be modeled by exponential functions. Some examples include radioactive decay, population growth, interest on savings, bacteria growth, and many other phenomena that occur in nature. You've probably noticed science and math go hand in hand. Tons of math in your science classes, think chemistry, or if you've taken physics, and tons of science in your math classes. Lots of our word problems have to do with sciencey topics, okay? So this first one, table below gives values for selected values of x. The function f is a decreasing function. Write an exponential function to model the data. Okay, so decreasing function just means as x is increase, y is decrease, right? It would make a backwards j. It means your b value, when we find it, should be less than 1, all right? And how many times have we had to do this over the last almost week? We know that when we put something in exponential form, we need the y-intercept, right? That's your a value. And we need the growth or decay factor. So we already know it's going to be less than 1, but to figure it out, you could take any two consecutive y values and make a fraction or ratio out of it. 24 divided by 36, math, enter, enter. To change it back to a fraction, gives you 2/3, right? So easy peasy. I think everyone understands how to make an exponential function at this point. Pretty simple. Riley. Okay, one thing I want to add to this that does come up in your homework and is one of your so I'm going to be talking about FRQ 2, I think this is from, on your AP exam. You have to be able to look at a table of values and tell lots of things. And, you know, for example, we were able to tell what the y-intercept was and what the growth or decay factor was. But you also need to know how to explain what type of function it is. Like, we did this with linear and quadratics, where we talked about equal length intervals for your inputs, and then your outputs were, you know, first differences. We talked about second differences, all that. We know this is exponential because that's the title of this section, but the words that you use are going to be really, really important. As we get into exam review time, we'll be going over this wording again and again because it's like verbatim. I am feeding you exactly what you have to say if you get an exponential function. So let's start by practicing it here. Input values, and this is how you start every single one, whether you're talking about linear, quadratic, or exponential, and other ones we'll get to. Input values are equal length intervals. Okay, so you have to say something about the x values. And that just means they're separated by exactly the same number, right? Add 1, add 1, add 1. It could be add 2, add 2, add 5. As long as it's equal length, you can use that sentence, and it always will be. And then output values, and this is the key word. No, you could say in just layman's terms, don't write this, I'm multiplying by 2/3. As the x values increase at equal length intervals, I'm multiplying by 2/3. But that's not the words they want you to use. Output values are, and here's the word, proportional. That is the key word right there if you're talking about an exponential function. Okay? And that's saying that's what we're saying. That's what that means. We're multiplying by the same number. As our x's increase, our y values are being multiplied by the same number. That whole sentence is just proportional. That's the word they want us to use, so that's the word we'll use. All right? Okay, example 2. An exponential function contains these two ordered pairs. So these are 2 points on some exponential function's graph, right? The function model is given to us like this. Notice there's the a times b to the x, and then there's a plus d at the end, where b is the base. Yeah, we know that. And d is a constant, meaning just a number with no letter. That's like your vertical shift up or down. Like, we're not graphing it, but this is what the equation would look like that goes through these 2 pairs. So we're going to go through a few steps here. The first one is write 2 equations that can be used to find the values of b and d. This is me starting to introduce FRQ2 from your AP exam. This is like one of the questions you're going to get. We have to write 2 equations. Given 2 points, it's literally just plug in x and y and plug in x and y. So one equation, so g of x would be y. For plugging in the 0, 6, that would be y equals 4 times, I don't know b, but I do have an x value I can use, and I don't know d. There's one equation, right? Just plugging x and y into the given equation. And we can do the same thing for 3, 1, 10, right? Y equals 4 times b to the x, which is 3, plus d. That's it. Being able to plug 2 points into an equation. Now, find the values of b and d. So we're going to do a little algebra here. So I'm going to show the work right here. In this equation, guys, b to the 0 power is what? 1. So I'm just going to get 6 equals 4 times 1 is 4 plus d. Obviously, you don't have to show this work. Yay, we got d. Found the value of d. Now, we can use d and plug it into our second equation and solve for the other letter we're missing. So that would be 110 equals 4b to the 3rd, right? Just multiply those 2 together, plus 2. Guys, let's not talk, please. So I'm showing more work than I would ever show. You don't have to show subtracting 2. You don't have to show dividing by 4. And how would I find b? Cube root it, right? Opposite of b to the 3rd is the cube root. So I'm going to do the cube root of this side, which gives me b, and the cube root of this side. And to remind you where that is, it is in your math button. You hit math. We worked with number 5 a lot. Remember, we had to do weird, like, 7th roots and stuff like that. But there's a special button just for cube roots, so number 4. And then 27 is 3. So we found D and B. And now write the model. So when we write the model, we would just need to plug in these 2 numbers, okay? So g of x equals, so 4 times, we found our b value, parentheses or dot, doesn't matter, to the x, and then plus d, we found d is 2. Okay? So pretty simple math. Any questions on that? Okay. Introducing a formula to you here that you're going to use in the next word problem. This is not something we need to write on our formula sheet. This is not something we have to memorize. You would see something like this on a test or the exam already built into the word problem. Here's an equation that represents blah, blah, blah. And it would say all this. So you would never have to memorize something like this, all right? So let's just talk about it. The size of a population P at time T. So P of T is the total population of something over time. With the initial size of that population, it's P sub 0. That makes sense. It's in the A sub 0 spot, right? Initial time before time starts, that's what the population was. Doubling, that means you're multiplying by 2. through the chart, right, or on your points. And so that's why there's a 2 in for B. And then doubling time of K. So time and then how often it doubles. And K and T have to be measured in the same units of time. So whether it's days or months or seconds or years or whatever. So we're going to use this formula on the next page. Optional if you want to write it on your next page. I don't know how it looks in your notebook, but I'm just going to write it right here so I have it to look at. Okay, so let's see what they give us in example 3. A certain fish species was introduced into a tidal basin 10 months ago. It sounds like something with time. We'll come back to it. Current fish population is estimated to be 220 and is doubling. That makes sense because that's that B value, right? Every 5 months. It's on your page before, right? So remember, now let's take it a step further. Find the initial size. Okay, that is going to help me narrow down what they gave me because it's telling me I don't have this, right? I need P sub 0. That's what I want, is the initial size. So the current fish, that's what it is right now. That would be P of T. Okay? So the question is, what did we start with 10 months ago? That's your time. And then K is how often you're doubling. And so K would be 5. And they're both in months, which is important. You don't have to switch one of them to match the other. 10 months, doubling every 5 months. Okay? So let's take what we have and plug that in. So we have P of T is 220. We don't know P sub 0 times 2 to the 10 over 5. And we have to solve the equation, right? So 10 over 5 is 2, right? So we can just make that a 2. So what that means is in 10 months, you're doubling twice. Does that make sense? 10 months, every 5 months you're doubling. So twice it will happen in 10 months. So that's just 4. 2 to the second power is 4. And solving for P sub 0 would just be divide by 4. And we get P sub 0 is 55. So make sure your answer makes sense. We started with 55. It doubled twice in that amount of period, and we ended up now at 220. So this is asking, 10 months ago, what did we start with if we have this right now, right? So just being able to read a word problem and understand what variables they're giving you. And sometimes it can be a little confusing, but then if you go to the question, like that really helped me know that 220 wasn't P sub 0 because it's asking for the initial. And then you kind of can connect the dots, right? Estimate the population of the fish 1 year. So they're saying when T is 1 year, what would P of T be? Well, we can make an equation now that we have our A value. So the equation would be P of T equals the initial times 2 to the T over K, right? Now remember, we know K is 5 months, 1 year. You wouldn't put a 1 in, we would use what? 12, okay? So whenever you need Y, like this is your output value, right? This is your Y, and you're given your input, or X, you can just either use your table if you were on your graphing calculator or plug in. Easy peasy, you're just plugging in 12 over 5, and this just goes right in your calculator, okay? So I have 2 to the power of 12, whoops, 12, let me start over. 2 to the power, and so real quick, I'm putting parentheses around my 12 over 5. I don't know if I need them or not, honestly. Sometimes in the moment, I don't know, but I know it won't hurt, so why wouldn't I just do it? right? Maybe you typed it in left to right and it perfectly worked out. I never ever let my calculator make decisions for me. I want to have control over the problem. I don't want to just trust that my calculator knows exactly what I'm trying to do. So I always, I usually will, whenever I do certain calculator problems, I'll usually have some student in the class at least once every year say, yeah, I was able to just type it in left to right and I got the right answer. Wonderful. I'm happy that happened, but just think about it. You wouldn't have known it was a right answer unless I was telling you what the answer was, right? So you just always want to be careful when you're taking a test that you take control of your order of operations. Anyway, that would be approximately, so that's the symbol for approximately 290 fish. Okay? So I want to remind you one more time. We have X, need Y in this problem. And I'll come back to why I'm making a big deal about it. We were given X 1 year. We needed to find Y, total population. Right? And I'll come back to Y with this question. All right. Suppose the half-life. Now, if you've taken chemistry before, some students say they have heard of half-life. Some students in chemistry say they haven't. Maybe it's a difference between honors and AP. I don't know. But half-life is the opposite of doubling. So it cuts in half. All right? It dissipates. I don't know what the sciencey word is, but if you have 100 grams of something, it has a half-life of 5 years. Every 5 years, it gets cut in half instead of doubling. Okay? It's just the opposite. So half-life of a certain radioactive substance is 40 days, and there are 8 grams present initially. There's that key word. Find the time when there will be 1 gram. All right? So B is going to be 1/2. Right? It's going to be a decreasing function. Your numbers are going to get smaller. 40 days. So that's how often it cuts in half, every 40 days. There are 8 grams initially. Now look, they changed this formula a little bit on us, but we can figure out what that means, right? A sub 0 would be your initial amount, and it says 8 grams initially. Find the time, that's what I don't have, where we'll have a total of 1. That's got to be my A sub t. Okay? 1/2? A times B to the X. So they're giving us 1 plus R. I don't really like how they did that formula. It's really 1 plus or minus R. So this would be 1 minus 1/2. This is the place where you put your B, where you had a double for 2. Here you'll have a 1/2. Okay? All right. So let's plug in. 1 equals 8 times 1/2 to the, I don't know T, K is 40. So this is similar to part B of example 3, except it's the opposite. We need X, which is T, our input, and we have Y, which is the 1. See the opposite here? I can't just solve this unless I know how to do it using logs, and we haven't done that yet. Whenever you need X and have Y, that's when we go to our calculators and we do the intersection, okay? So you can put these 2 equations. One of them can be Y sub 1, one of them can be Y sub 2. It doesn't matter which one, okay? And all you have to do is, I would clear your RAM, because the answer is probably in your, well, maybe not, because they were doing their homework. But you want to know how to type these in. So again, it doesn't matter which side of the equation you make y1 and which side you make y2. I'm also going to use 0.5, because why wouldn't I? That's so much easier than typing 1/2. 8 times 0.5 to the power of x over 40. And we graph. And you can see on my screen here, you can see that y equals 1. And you can see that it's coming, but it's happening to the right. So I'm going to go to my window, and this is where you have to make a guess. You don't know. I know because I have the key here, but if I didn't know, I might say 50. I might try 100, and I see if I can see the intersection. You have to have the intersection on the screen. I'm getting there, but I'm not there yet. So you have to be okay with going back and changing your X max to something else. Maybe 150, maybe you try 200. Remember, there's not a wrong answer. As long as the intersection is there, which now it is. It's not super clear, but that's okay. I'll talk about that also. As long as you can see where they intersect, you're good. If you don't like that because it's hard for you to see it, then you could move over a little bit more. You can play with it as much as you want. But the good news is intersection is the easiest of all the calcs. Okay, so you go to second calc, and we've used almost all of those in here. Guys, intersect is my favorite because guess what? When you do intersect, you don't ever have to mess with these buttons at all. You can literally hit enter 3 times and it goes right to the answer. It's saying first curve, that just means first graph. Your cursor is always going to be on one of the 2 graphs. So that's perfectly fine. Why would you even want to move it? Why do more work? Just hit enter. It will always jump to the other graph. You can see mine jumped. That's fine. Right there is perfectly fine. Hit enter again. You always get that guess screen. Yes, so there's my 3rd enter. And then it says when y is 1, x is 120. Okay, so that is how when we need our input and have our output, we use that method right now. Yes. It's in calc. So you have to hit second because it's blue. Yep. The number 5. Yep. And I literally just hit enter, 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 and it gave me the answer. If anybody else missed that, call me over. I only have one more example, and it's fast to do with you. So 120, what? Oh, we're talking about days here. 120 days it would take. Okay. Okay. Exciting review problem here. And I get so excited to tell you about this problem because what this is telling us to do is to write an exponential function for this graph. You have 2 points. This is just like the first example we did. Given 2 points, but they walked us through a bunch of steps. Write 2 equations. Find the missing letters, then we plugged into the equation. They're just jumping to, give me this. And let me show you in the past what my students were instructed to do on this question and why you don't have to do it. So this is what I did the last 2 years, okay? I took the x and the y, and I plugged them in. Remember, make my 2 equations, solved, and I get a lot of work. I mean, it's algebra, so it's not difficult for you guys, but it's a lot of work, okay? As I become a better and more informed AP pre-calc teacher, I learned this summer that this is going to be FRQ2 on your AP exam. It's always on FRQ2, and FRQ2 is calculator active. So you can actually use, and we'll go through those steps again, using your calculator to get the equation. It's very, very nice. You can always use your calculator. Why didn't I do that on the very first example that we did? Or, sorry, the second example. Why didn't I do that on this one? Because of the D, you can't use your calculator. If the equation given to you has any kind of transformation in it, in other words, it's not just the parent function, it won't work in your calculator. All right, so what we're going to do is do this in our calculator. If you want to clear your RAM again, I would advise that. And guys, remember, just like the last test, you had to know how to do this. This is going to be on the next test. It comes up a lot in this class, having to do this. So we start with stat, enter. And we just have 2 x's and 2 y's, right? So you type in -5, enter, 6, enter. And 12, enter, and 0.5, enter. Right? Those are all my x's and y's. Do you remember what button we hit next? Michaela, you awake? Sat, over to calc, and it says to write an exponential function. We've done this for linear, quadratic. We'll use it all the time. So find exponential. I'll tell you it's 0. It's right after number 9. So you can just remember exponential 0, and you can just hit 0, or you can arrow to it and then hit enter. This screen should look familiar. Do we remember how to save it? Alpha, trace, enter is the easiest way. She gives a different way of doing it. She actually didn't say it. She just said store it right here. If you want to remind yourself and write it here, fine. But, I mean, we should be getting to the point where we just kind of know these steps because it's the same steps every time. right? And it's going to come up again and again and again and again, right? And I don't even know, I do because I am a teacher. I know what's coming up in a second, but I don't always know, do I need to store it? Because you don't have to store it to get the A and the B to write the function. You could skip that step. But what if then I needed to look at the table or look at the graph or something? I'd have to go back in and save it. So it takes 2 seconds to type alpha trace enter. So I might as well just save it every time, and then I'm ready for anything that comes afterwards, right? And so you can see we get some decimally answers. No big deal. We just round to 3 decimal places always. And there's your exponential function. And if you want to compare the amount of work, I still got the same answer, A and B, but by hand it was a lot of fancy algebra, okay? And this is asking for the y-intercept as part B, so I really didn't need to save it, okay? I just want you to get in the habit of it. Y-intercept, I could look at the table and see when x is 0, what is y, but why don't I have to even do that? Why don't I have to go to the table? It's just A, right? Your A value is your y-intercept. It's right here. 2.83. So when x is 0, y is 2.83. Okay? So in your homework, it's like number 8 and 9 are the same question. In my key is all the work doing it by hand. You do not need to do it by hand. You can use the calculator if you want to for 8 and 9, and why wouldn't you? Okay? Okay, so here is homework. And I'm going to tell you something about the first 4. She gives a whole bunch of instructions and then does way more than even are in the instructions. Guys, all I want you to be able to do for the first 4 problems is say, is it growth or decay? I don't care if you write the y-intercept and all that stuff. I know you guys know what the y-intercept is. It's the A value. But just say growth or decay for 1 through 4. Again, there's a whole lot of extra there in 1 through 4. Just be able to say growth or decay. That's really all that matters. And 8 and 9, you can use your calculator if you want, or do it by hand. Whichever you would prefer. Scan this. There we go.